Hi guys, I hope you are all doing well and welcome back to another video of class 9 for mathematics. Today we'll be starting with our chapter 7, that is the mathematics of maybe introduction to probability. In the last video we have covered the concept of perimeter and area, that was chapter 6. I hope you have practiced well and have gone through all the concepts. So today we'll begin with our seventh chapter, that is, and it is the second last chapter of your class 9, that is the mathematics of maybe introduction to probability. So yeah, we'll start with the chapter probability. So first thing comes that comes in your mind is what is probability, right? So you have gone through many of the real world situations where you are in a situation like when you need to predict that what is going to happen, or you just say in a subjective way like this will happen, this will not happen, this is more likely to happen, or this is not. So basically, probability is a type of measurement similar to how we measure quantities like length, area, or volume. But instead of measuring the physical quantities, here we measure the likelihood of events. So, for example, if we ask that is it going to rain today, or it might rain, or it might not rain today, or whether you are going to win this competition or not, or whether if you are playing Ludo, let's say, or snakes and ladders, then you say that okay, I'm going to throw my dice, and what if it comes six, or is it what are the possibilities that it will come six, etc. things, right? So basically, these events are examples of random events because they are very random in nature. Is it going to rain today, or will our school win the inter-school hockey match tomorrow? Right. So they are very random events. That is why these all examples are called random events. Okay. So now we also know the possible outcomes for these events, right? So if I ask you the question, is it going to rain today? The Your answer would be either yes or no, or maybe it could be it is more likely to rain, or it is less likely to rain. Okay, but we cannot say it firmly that whether it will rain or not. You may say that we use weather forecast to predict whether it is going to rain or not. But yes, but in that case also, the weather forecast is also the prediction and not a certainty that yes, it is going to rain. That is merely a prediction, and it may happen that the prediction goes wrong, and that is very natural in nature. So that doesn't make any difference. Okay. Okay. So we also have element of chance or randomness that involve every time an event takes place. Every time an event takes place, there is a chance or randomness that is going to happen. Now, I am recording this lecture. It may happen that my laptop crashes down, or it may happen that it my video would go smoothly and it would be recorded without any disturbances. Again, any event, there are chances and there is some or the other randomness, right? There always, with every event, there is a randomness or a chance associated. If you take any event. Now, if you are playing cricket, you are going to bat. Now, when you are going to bat, it may happen that you score a 1 run, you score a 2 run. The bowler may throw a wide. You may hit a four, you may hit a six, or it might happen that you may get out. Okay. So there are every event is associated with some or the other chance or randomness. It depends on event whether what are the chances associated with it. For example, if I throw a dice, what are the chances that I'll get a four or not? So there are only two answers to it, either yes or no. Okay, only two chances or two number of randomness associated with it. But now, as I said, if you are going to bat, there are many chances that are going to happen. Like you can score a single, you can score a double, you can hit a six, you can hit a four, or the bowler can throw a wide. Anything that can happen in that case. Okay. Okay, then now the question comes, can we predict these outcomes with 100% certainty? Now we can answer it in two ways, that is the subjective ways, and in practical way also. Now, for a subjective way, we can say, based on we can answer those questions based on the evidences that we have. Now, if I say that there are many dark clouds in the sky, so it is more likely to rain. Yeah, so basically the dark clouds are the is the evidence over here, and more likely is the subjective probability that is associated with the rainfall that I'm going to predict. Or maybe out there the sun is very bright uh, and is shining, so it might happen that it would not rain. Like I can say that it is less likely to rain. But what if there is a neutral weather in well weather in your locality, and you may say that there there are equally likely chances that it would rain or it would not rain. Okay, so this is what we are just predicting the rainfall on the weather conditions, and that is why that is a subjective probability associated or given to the event of today's rainfall. So from this we can also say that there is therefore probability deals with uncertainty or a chance, right? Because these all things are very uncertain in nature. You cannot predict accurately that what is going to happen. Okay, cool. So thus understanding how to objectively estimate the probability of events is crucial in many aspects of life. Like now, for us, it might sound very less important that okay, yaar, if there is rain or if there is not, that is other thing. That would not matter as much more. But for many other individuals, it might be a very important decision for them. So to predict what is going to happen for an event objectively or in practicality, in terms of numbers, in terms of values, that is very important and crucial for many other things associated with many other individuals. Maybe it is not that important for us, but for some other person, it would be important, right? So therefore, in this chapter we'll learn how we can measure probability more objectively. That is the ways of collecting evidence that can be used for an objective estimate of likelihood. Okay, okay. Moving further, we have the question arises that what is randomness? Randomness refers to a situation or action like the tossing of a coin or rolling of a die, where you cannot predict exactly what will happen. Now, if you are tossing a coin, there are two possibilities that will come up. Either you could get a tail or you could get a heads, right? So any of these two is going to happen, right? Now, if you are rolling a die, it may happen that you'll get a one, two, three, or four, or five, or six. Out of this, there is no other possibility that is gonna come, right? So this suggests randomness, right? So all of these observations that either you'll get heads or tails, or you'll get one, two, three, four, five, six. These observations are called experiments or trials in probability because of their and they are called random because of their unpredictability. You cannot predict it whether you are going to get one, two, three, four, or five, or six when when you roll a die or when you throw a die, right? So because of their unpredictability, we say that they are random in nature. Okay. Now, next up we have random observations. A random experiment is something you can repeat, where every time you do it, the result might be different and you cannot know the outcome in advance. Okay. Now maybe now I have to roll a dice. I don't know whether I'm gonna get one or two or three or four or five or six, right? It is different. We cannot know in advance what would the result be? What would be the result, right? So therefore, these are called random observations and they're associated with a random experiment. So, the probability is the area of mathematics that studies randomness and how likely a specific outcome is to happen in a random situation. For example, when you toss a coin, the probability for heads is 1 by 2 and for the tails is 1 by 2, which is equally likely, right? Now, how do we calculate this probability? We'll learn it further, but for for this point of time, you can refer this. In a random experiment, every outcome has a chance to occur, but you can only determine the likelihood or not the exact result. This is the likelihood, not the exact result. We cannot say that, okay, oh yeah, this is correct. I'll get a tails only. If that would be a case, so this probability would have been one, not 1/2. Why? I'll teach in some time. Okay. Next up, we have used the example of rain many a times, but for rain we cannot we cannot predict whether it is going to rain or not, because it depends on many factors such as temperature, humidity, wind patterns, and pressure. So for us, this is very tough, and let the weather forecast department take care of that matter. Okay. Okay. Now, what is the probability scale? So basically, any probability. Let's say I have an event A. Okay. A is an event. So the range of the probability for the event A is the probability of A is divided by P of A. The range of probability P of A lies between is 0 to 1. So basically, whatever probability I calculate, it cannot go less than 0 and it cannot go higher than 1. So it lies in between 0 to 1 only. So maybe so there are we can divide it into 3 4 cases. Like if I get 0, if I get point 0.5, 0.25, if I get 0.75, or if I get 1. So maybe for an event like this, if we say that its probability is 0, like if its probability is 0, so we can conclude that that event is impossible, like it will not happen. If I say that your school team will not win tomorrow, and your probability of winning the match tomorrow is 0, then this is so it would be not possible for you to win the match. So the possibility of winning a match tomorrow is 0. So therefore, it is impossible for you to win the match tomorrow. This is what a zero probability refers to. Okay. Now, if I say 0.25, so maybe if I convert this into percentage by multiplying it by 100, I get that 25%. So maybe I can say that it is less likely for you, in subjective way, we can say that is less likely for you to win the match tomorrow. So you can say that 25% is a probability. Out of 100, there is only 25% chance that you will win the match tomorrow. So you can say that this is a very less likely event to happen. So this is what maybe 0.25 uh, refers to. Okay, one more thing that you need to notice, you need to understand is I am just taking this as an example and not a fixed thing, right? So only you use it as reference and not like a very certain thing. Hmm. Now, if I say again, if I multiply it with 100, I get 50%. Now, if I say I have a chance 50% for an event to happen, that there are 50% chances that you will win tomorrow. So therefore, there are 50% chances that you are going to lose tomorrow, right? So both are likely. So we can refer it as equally likely, because any of the cases can happen. Equally likely. Okay, so there are 50% chances that you could win or 50% chances that you could not win. So the chances of winning or losing are equal. So therefore, we can say that they are both this event the probability, like both the cases are equally likely. Now, if I say 0.75, therefore 75%. So now you can say that 75%, there are 75% chances that you could win tomorrow. So now this is more likely to happen. That, sorry, this can be suggested as more likely because there is a more likely chance that you could win tomorrow, because there are 75% chances, and out of 100, 75 is a great number, right? Now, if I multiply it with 100, I say 100%. So if I say you are going to win tomorrow, for sure, for 100%, there are 100% chances that you are going to win tomorrow. In practical cases, we cannot say like that, but okay, in a subjective manner, we can, if we say like you are going to win 100%, you are going to win tomorrow for sure, that probability of your winning is 100%, then we can say that it is a certain event, or maybe it is going to happen. That is why its probability is 1. It, it is certain to win, certain. Okay. Now we have, that is why we have a probability scale. So you can see here that we have a impossible, that is 0, less likely, even chance, more likely, certain. I've just divided it out of 100. So here it comes 0, here is 1. So here we get 0.25, here we get zero point 0.5, and here we get 0.75. That is the only reference. Do not consider it as a very certain thing, right? Okay, here we are given that, and we have events and what it means. Okay, getting a number greater than 6 on a die. Now you know that for a die, we can get one. If I roll a die, I'll get one, two, three, four, five, six. No number beyond this, right? Now here it is saying that getting a number greater than 6 on a die. How will I get a number greater than 6 on a die, right? So there is no possibility that could happen. So therefore, that means it is impossible. Dice only have numbers from 1 to 6. It is impossible to happen. Okay. Next up, we have rolling a 3 on a standard die. So rolling a 3 on a standard die is less likely to happen, but not impossible, as one of the face of the die is 3. ठीक है, it is possible but it is less likely to possible. Maybe I could say that no, ये die में 3 कम आता है. Maybe I could say like that, but rolling a 3 on a standard die, it is less likely to happen. Now flipping a coin and getting hits. Now if I flip a coin, either I could get one, or I could get either I could get heads, or either I could get tails. So therefore, getting heads is equally likely, like even chance, because heads और tails are equally likely. Because एक तो heads मिलेगा, एक तो tails मिलेगा. So therefore, दोनों का chances 50-50 है ना, कि एक तो ये मिलेगा, एक तो वो मिलेगा, right? Okay. Now we have drawing any number from 2 to 10 from a deck of 52 cards. Now, see, there are 36 cards in a deck of 52 cards with numbers from 2 to 10, right? Because all of the cards you can see are from number 2 to 10. If you just take out the Joker, Raja, Rani, then it is more likely to happen to get a number between 2 to 10 from a deck of 52 cards. Therefore, it is a more likely event. Now, if I now next event is choosing a red sweet from a bag of all red sweets. Now I know that the bag is full of red sweets and choosing a red sweet. So it is certain to happen that if I put my hand into the bag and I get a sweet out of it, it would be red only, because all the sweets are red. There is no chance that I could get a yellow or a brown or a blue sweet, right? There is 100% chance that I'll get a red sweet from the bag if I put my hand in it and I get a sweet out of it, right? So therefore, all sweets are red. There is certain. So it is certain to happen. Okay. Next up, we have exercise 7.1. I hope you can do it on your own. It is a very small exercise though. ठीक है. Now measuring probability objectively. So there are two main ways of estimating the probability of an event objectively. Firstly, using evidence from experiments. We call this as experimental probability, in which you are given with the event and the outcome also. So you just need to apply the formula and get the probability. Next is using theoretical methods. This method approaches the possible, and here we need to assume the possible outcomes, and then we need to calculate the probability. So therefore, this is called a theoretical probability. We'll get through it. We'll learn it further. Okay. First is experimental probability, performing observations or experiments. Okay, firstly, you need to understand what is an outcome. The event is a result of experiment and is called an outcome. ठीक है? The set of all possible outcomes is in an experiment is called a sample space. So basically, if I roll, if I toss a coin, I'll get heads or tails. So basically, this is my sample space, and it is denoted by S. So what is it? What is the sample space? That the set of all possible outcomes in an experiment. Now, if I roll a die, there are what all are the possible outcomes? Either heads or tails. So this is my sample space. If I roll a die, I'll get I'll get one or two or three or four or five or six, right? So here this becomes my sample space because these are all the possible outcomes. So therefore, the set of all the possible outcomes is called a sample space. ठीक है. Now, how do we calculate the experimental probability? The formula for experimental probability is the number of times the events occurred upon the total number of trials. We'll see an example. So basically, a die is rolled. The possible outcomes are 1, 2, 3, 4, or 5 or 6, right? So the sample space becomes 1, 2, 3, 4, 5, 6. Okay, cool. Okay, let's take another example. Let's take another example. Suppose you roll a die 50 times and it lands on 4 exactly 8 times. Then okay. So here, now we are given the total number of trials. The die is rolled 50 times. So number of trials is given. Number of trials is given. Okay. And it lands on a 4 exactly 8 times. Number of times the event has occurred. So basically the event over here is getting a 4 and it has landed on 4 exactly 8 times. So therefore experimental probability of rolling a 4 is 8 upon 50 because it has landed 8 times upon 50. That is equal to 0.16, or if I multiply it with 100 I get 16%, right? We can also say that the relative frequency of rolling a 4 is 8 upon 50. Now, this probability is based on the data given in the question, right? We have not assumed anything from our side because it is experimentally done. They have rolled a die 50 times and they have experimentally got the value, right? So, therefore, this is called as experimental probability. So I hope you have understood the concept of experimental probability. If you do not understand it, you can just put it in the comment section. I'll definitely try to clarify it. Right? Okay. Next up, we have the theoretical probability. The theoretical probability studies the likelihood of an event happening based on all possible outcomes being equally likely. It is what we expect to happen in an ideal, perfectly fair situation. In this scenario, no experiment or data is required. Theoretical probability is usually denoted as P or P event or P outcome, right? So the formula for theoretical probability is the number of favorable outcomes upon the number of possible outcomes. So in experimental probability, I've seen that we are given with the number of events occurred and the total number of trials because it has been performed experimentally. But here we need to assume what are the equally likely situations going to happen and in a fair way. And so therefore we need to get the values of number of favorable outcomes also and the number of possible outcomes also. ठीक है. Example is if you roll a die, a standard six-sided die, what is the theoretical probability of getting a 4? Now, firstly, we need to calculate. To approach this question, we need to get the sample space, and therefore we'll write the sample space over here. The sample space is 1, 2, 3, 4, 5, 6. So basically, uh, sample space is the set of number of possible outcomes, right? So we have got the number of possible outcomes over here. So the number of possible outcomes for rolling a die is 6. Okay, possible outcomes are 6. Either I'll get 1 or 2 or 3 or 4 or 5 or 6. Any of these is the possibility. So it is the number of possible outcomes. Okay. So now we have asked that what is the theoretical probability of getting a 4? So now we need to calculate the number of favorable outcomes. Okay. Now from this sample space, we can say that there is only one chance what is the number of favorable outcomes? That is only one because only once we have a 4, right? So either I can get a 1, 2, 3 or 4 or 5 or 6. So therefore I can write it as 1 कि number of favorable outcomes कि कितनी बार हो सकता है, that is only one, right? मैं एक बार अगर डाया रोल कर रहा हूँ तो ऐसा हो सकता है कि एक ही बार मुझे 4 मिले या उतना ही 6 में से it is only one times that possible, it is possible that I could get a 4. So therefore, number of favorable outcomes is 4, is 1, and number of all possible outcomes is 6. So therefore, probability of rolling a die is 1 by 6, number of favorable outcomes upon number of possible outcomes. So what are the favorable outcomes? Number of favorable outcomes to get a 4 is only 1, and number of all possible outcomes is 7. So therefore, the probability is 0.1666, or maybe we can write it as 16.7 percentage. ठीक है. Next up, we have a letter is picked at random from the word probability. What is the probability of picking the letter B? ठीक है. Now, what are the number of possible outcomes? Outcomes are basically we have picked up a letter. So what are all the letters? P, R, O, B, A, I, L, T, Y. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, right. So we have I and B twice, right? Okay. So now, if I have picked up a letter, I could get any of these letters, right? So the number of possible outcomes is equal to 11. Okay, number of possible outcomes is equal to 11. Now I need to calculate the number of favorable outcomes that I pick a letter B. So now here B appears two times, right? So it may happen. So the number of favorable outcomes is 2 because there are two B's in the word probability. Okay. So now the probability would be 2 upon 11, that is 0.1818 or 18.2 percentage if you multiply it with 100 by 100. So this is how we calculate theoretical probability. One thing that you should notice is the probability is again lying between 0 to 1 only. Okay. It is not exceeding 1 or 0, right? Okay. Now, analyzing statistical data using probability, you will just read this example and you'll get this concept. That is not very hard to do, hard to understand. Okay. All of this theory part, I'm not going to explain you because that is the self-study part. You should do it on your own and you can do it on your own, not a problem. Next up, we have gambler's fallacy. One concept that is gambler's fallacy. So it might happen when you are playing some Ludo or something with your friend, right? With your cousin. So it might happen that sometimes you get a six three times in a row. कि ओ मैंने six डाला six डाला, and you assume that okay, abhi now for the fourth turn also I'll get a six, but that is your assumption and that is not what probability suggests. Okay, in the terms of probability and by probability, it might happen that you have got three times six in a row, but for the fourth time again you will get a six or not. That probability is the same as that you had earlier because if you will get a six or not, so basically one, two, three, four, five, six. So if I calculate the probability of getting a six, it is one by six, right? Because number of favorable outcomes one and total number of outcomes six. So if you have got if you have got six three times in a row, for the fourth time you might feel that you will get a six again, but the probability again here is one by six only that you will get a six. So the probability of getting six at the fourth time is again one by six, not like it is one because you are feeling that you will get a four because earlier earlier in all the three chances you have got a six. Okay. Similarly, you might get us heads if you flip a coin, you get heads six times in a row, and then you might feel that yeah, and then the next flip you will get tail because tails haven't come up for a while. However, the probability of getting tails again would be 1 by 2 or 50% only. Okay. I hope that you have understood the gambler's fallacy. Okay. Uh, Also, we need to we need to focus on a concept of fair and unbiased. When we speak of a coin, we assume it to be fair. That is, it is symmetrical so that there is no reason for it to come down more often on one side than the other. Right? We call this property of the coin as being unbiased by the phrase random toss. Basically, if we toss a coin, it is very like a very one in a million chance that it would stand on the center line, right? I would either get a head or a tail. Okay, so this is what we call as being fair or being unbiased because we are not biasing on one situation. We have got probabilities for both the situation, and that is equally likely to happen. Okay, I hope that's understood. Okay, elements of probability, sample spaces, and events. So we need to focus on the thing that what is sample space and what is events. So basically, the sample space includes all the set of all possible outcomes is sample space. No outcome should be listed more than once in a sample space. And the sample space is denoted as S, and the number of elements in sample space is denoted by n of S. Okay, small n of S. Examples. Okay, the sample space for whether it rains tomorrow could be S is equal to rain or no rain. That is, you can say that is yes or no. And the sample size is two because we have two elements, right? Then you have a tossing a coin. If you have your corner, you toss a coin, either you could get a heads or you could get a tails. So sample size is again two. Rolling a die, 1, 2, 3, 4, 5, 6. Sample size is six. If you tossing two coins simultaneously, so it might happen that for both the coins you get heads, or one heads, one tails, one heads, or both tails, right? So therefore that is a sample space, and that size is four. Events. An event is any single possible result or combination of results that might happen when you perform a random action. It is like choosing particular outcomes from all the things that could possibly occur. An event is a subset of a sample space. So basically, what our event is it is the an event is the only single possible any single possible result or combination of result. So basically, if I toss two coins simultaneously, this is my sample space. But event is if I say at least one coin should show a head, right? So the at least one means any minimum one time. So minimum one time head should occur. So I'll get a head, tail, or tail head. So heads is occurring at least one time. So that is an event. Okay. Rolling a six-sided die. So this is the sample space 1, 2, 3, 4, 5, 6. Event, the number rolled is greater than 4. Now the number should be greater than 4. So event should can have 5 or 6 as well. Okay. 5 भी 4 से बड़ा है, 6 भी 4 से बड़ा है. So that is how we define event. Okay. Next up we have exercise 7.3 that you can do it on your own. Okay. Diagrams. A tree diagram is a visual representation used to list all possible outcomes of a multi-step experiment. Okay, a multi-step experiment involves a series of independent trials. So basically, if we toss two coins two times, right, and not simultaneously, we'll toss one coin, then again we'll toss it for the second time. So how do we solve for it? Experiment here, we have to toss a fair coin two times. Okay, we have only one coin and that we need to toss two times. Okay. So पहले coin है. Okay. So we have tossed the coin. So either I could get a head or I could get a tail. For both the cases, the probability is 1/2, which is written over here. Right. ठीक है. I've got 1/2, 1/2. ठीक है. Now for the first case, now I have let's assume I have got a head. Okay, now I'll toss it again. Again, there is a probability that I could get a head or I could get a tail, right? So again, the probability is 1/2, 1/2. And for the second assumption, if I've got tails in the first part, again I have tossed it for the second time. Then either I could get a head or I could get a tail. Again, the probability is 1/2, 1/2. So therefore, we could say that again, if I consider an event of getting heads twice, so I can say that getting heads are twice. So first probability was 1/2, so 1/2 into second probability is again 1/2. So basically heads and heads I want, right? So 1/2. So that is equal to 4. You can calculate it using the sample space and the theoretical probability ka formula also. So basically, these are all the number of possible outcomes, that is 4 in the denominator, and getting heads for both the times, I could say 1, right? So therefore, 1 by 4 is the probability of getting heads twice. So this is how we use the tree diagrams to calculate the probability. Next up, you have exercise 7.4, and we are done with this chapter. I'll just quickly summarize what we have learned so far. So probability is a measurement of the likelihood of an event. Probability is expressed on a scale from 0 to 1. So therefore, probability of any event ranges from 0 to 1. Experimental probability का formula is number of times the event occurred upon the total number of trials. Both of these would be given in the question. Then the theoretical probability का formula is number of favorable outcomes upon number of possible outcomes. Then we have what is sample space, what is event, and what are tree diagrams. I hope you have understood all the concepts and all the examples that we have solved in this video. So go through the chapter once, read all the concepts, visit them regularly, revise them, and solve all the questions. Probability is something that you should solve it on your own. As much as you solve it on your own, your concept your concept gets clearer, and you can understand things easily and predict things easily and assume things easily because probability is one of the chapters in mathematics that for me that is thoda difficult to solve because I'm not very good at predicting things and assuming things and maybe putting logic using logic, but that's okay, not a problem. Practice again makes a man or woman perfect. So practice it, go through the textbook, revise all the concepts, solve all the exercise questions as well as the solved examples also. I hope you have got all the concepts, you have understood all the concepts. Thank you so much for watching this video. We'll meet in the next video. Thank you so much for watching. Have a good day. Take care and bye bye.
वीडियोस बनाने हैं, फिल्मोरा है ना।